Not yet, probably.
Oh.
I mean, are they open?
You can't just come and go and come and go.
Why have to pee now?
Dude, that's too much. Yeah, TMI.
That's not even a TMI. They're open.
So you tell me it's
Go
gonna
ahead.
shit.
Yeah, you're okay.
They have to shoot.
Watch your mouth.
I doubt it.
I wouldn't.
If you guys want to take a minute to fill out your check-in forms, if you haven't done that already, go ahead.
Cody usually does something with video. Sitting on a bucket. Sitting on a boat.
Then we'll start with the exponential equations.
Cody's birthday is.
No, when I was watching it, because I pulled it up on my phone, she was talking about her. She wasn't even talking about look up Charles Dickens' Opium Addiction, or Bela Lugosi, or Florence Nightingale, or Marcus.
Is it October? Yes, it is. God, that's like
Is it like November 16th?
I thought it was November.
What's my birthday?
July.
This says he's I can't look at his right because I always.
July
25th. 17th?
Smile, baby.
Is that good?
Yeah, I was gonna say.
I wasn't thinking.
Wow. 7-11. My dad's is
Lots of it looks like there aren't many great matches for yourself.
My brother's is July.
Oh, it's okay.
Yeah, look it up on your phone.
It still would show up on here.
He was almost on 4th of
No,
July.
this is the computer.
He was almost on
It's
4th
Go
of
back to
July.
everything.
They don't log it. You can look it up, and then once you page number, find out more.
Yeah, but if you pull it on here, it's not locked.
I know, but there's nothing that comes up on the template.
He's all I got is he said that he doesn't get his license until like fourth junior year.
Opium.
That sucks. So fourth junior. No. You just sat in so much German.
Huh?
You just sat in so much German.
All right, we're gonna go over the exponential equations assignment. Some of these questions are like what you've already had, so those shouldn't be too bad. Some of them are a little bit different. We'll go through those though.
That's a school Chromebook.
Not the $3,000 Chromebook. I guarantee Trisha's. She heard that.
She probably
knew exactly
did.
what it was.
I get an alert every time.
Relax. Bruce. Bruce. You have the patch
question, a price question?
I haven't even done the first movie's
Hey
questions.
Bruce, you got that $100 you owe me?
It's gonna be 140 tomorrow.
That's unfortunate. Last guy that said no got his legs broken.
Who's this last guy? Gerald. Gerald Cockleberry. Only.
So open up this assignment. This one's exponential equations. It has today's date on it. Question 1 is a percentage growth. So that's like the last 5 questions from the last homework. Do you guys remember how to do that? It's the equation. It's the equation on the right on the board.
Yeah. They're just one word answers.
What?
Not one word, like one sentence.
Work on this, Cody.
Wait, you only need a sentence?
No, I don't
No, I
think
think
you
it's
need
like
a lot.
3. He's giving full credit. Oh.
Oh, you gotta do 100%? Alright, I'll change this. You don't know.
We literally watched the last.
Twice?
Yeah,
We watched it last year too.
watched this all.
Sorry for blowing up. That's on me, guys.
Yeah, you're right.
Are you guys good on number 1?
Yeah.
Yeah.
Hold on, I'm getting signed in.
No, I'm not even on this.
Dude.
Lies.
Eli. Knock it off.
Talk to the
Talk to the butt. Talk to the man at Pizza Hut. You're laughing at that, Mr. Sindel?
Haven't heard that one before.
Yes, you have.
silly boots.
Silly.
My mom told me not to talk to the man.
Gotta play it safe.
She said it was dangerous.
And that.
Okay.
So this is like the last 5 questions in the last homework. It's that equation on the right on the board. So
It's gonna be
on the chalkboard, you see that on the right?
The thing about
Jake,
Jake
that's
is
never
well.
well. Terms of need of somebody to do petitions from that. Jake has volunteered to do the reading.
So go ahead and try number 1. Let me know if you have trouble.
I should have said.
You guys should be working.
is in.
Eli, Nolan.
Wait, so can I just put the T if it's
It's
just
not
annual
flavored.
growth?
Yeah, it's just gonna be years. So yeah, put T for the first one. It's a variable. And then for the second one, you would plug in, for my example, be 8 because they're going to 2008. Just the number of years after 2000. So here's the example for mine.
Can you just show me? Yeah, that. Yeah. Okay, that's what I have for mine.
So you have the starting population times 5% beyond 1. Shh, guys,
Hey, I still got flavor.
I can't breathe.
quiet, please.
Shut up, George.
And then raise it to the variable T,
Yeah, I got it.
and then just plug in what your years are. Round down. We good? Everybody, get on number 1. All right, 2 is a compound interest question. The first part, you just got to identify what each variable is. And then the last part, you plug in 7 for the years.
So would yours for the first one be 6,500?
Yes,
Okay. And then the rate would be the percent.
as a decimal.
So would it be 0.021?
Very good.
There's not really hard.
And N, it's compounded quarterly.
So 1/4.
Yeah, so the N would be 4 down here and up here.
Wait, where did you see compounded for?
And my question, it says that it's underlined in the last part of the first sentence.
Okay, minus 2.
Okay.
And then you do that and
Yeah, first you identify the variables, and then they want to know when t is 7. For me, it's 7.
yeah, that's mine is 9.
Then you would plug in 9 for t.
So where do you put the 4 though?
For me, it's for n, so n would go below r. So I'd do 1 plus r divided by 4, and then I'd raise it to 4 times 7, which would be 28.
Gnats, dog.
What's your question?
Yeah.
Wait. So
I said, can I go to the back? All of them.
Why?
it'd be 1 plus, would it be
0.021 divided by
over
4.
4?
Yeah. You can just use division symbol.
Okay.
That'll work best.
Wait, is this a different document?
Yeah.
And then when you raise it to the power, I'd put, if you're gonna do 4 times 7, I'd put parentheses around that so that that's all in the exponent.
You have to do 4 again.
Yeah, 4 times the number of years. Remember compound interest.
Okay.
No, I think.
So these are like daily, Wait, do you have to do like the, oh yeah.
Really?
So take it to cents, so 2 places after the decimal.
What? I have it wrong.
Was your part A correct?
Yeah.
So it might be how you enter it. I would do 1 plus. For me, it'd be 0.021 divided by 4. That should be, then press enter, or equals. And then raise it to, I'd use parentheses. Put in your fraction. Or I'm sorry, your multiplications, 4 times whatever. Equals, and then times the population, 6500 for me.
Oh, did you listen to right ways and all? You like right ways?
You can always just use Google, you know?
Like 300.
So like, if you just type it, you know? It should give you your, so that'd round to 41. You can just type it. That may be easier if you're having trouble with how you enter it on your calculator.
We're so annoying.
Use asterisk to,
For multiplication, yeah.
What? Charlie Crow.
did Amber lose some?
The first game was close, the second set was not. It doesn't help you broken watch it actually got off. Motivation, battle to attitude.
Any questions on number 2?
Oh, she's not bad.
Number 3 is like number 1.
The whole team But it's really just one person can sit there.
Oh, actually, it's not like number one. It's a little different. I'll just show you this
What
one.
is that?
We haven't gone over continuous yet, so just do it like this. You're going to put E. E is a special number. It's like 2.71. I'll explain that later at another time. But just put the percentage up above times T, and then put the starting population. Then you'll just plug in 8 for T. You should have a button on your calculator for E, or you can just type it into Google. So I would do 6,000 times E raised to the 0.06 times, was it 8? Let's see. Yeah, it was 8, so 9696. If you just put E, it'll know you're talking about this special number. It's like pi, it's an irrational number. It goes on forever with the decimal, but we haven't talked about that yet. Is question 3 okay?
Yeah, I've kind of just given up.
Just put in the population, then E, put the rate up here, and then put a T. We'll go over those more later, just,
Can we just do this assignment next week?
no.
Really?
Yeah, it's
What
right
is that
there.
there?
Oh, it's right here.
All right, question 4. You have 1/5 raised to a power is equal to 125. So with these ones, you want to try to figure out what power on the left would make 125. So let me write that out for you. So what you want to notice with these is that you have some power on the left and you have some power on the right. Now on the right, 125, 5 times 5 is 25. 5 25s make 125. So that's actually 5 times 5 times 5 is 125. So that means 125 is actually 5 to the third. So, 1/5 to what power is the same as 5 to the third? So one thing you have to notice with these is that in order to take it from 1/5 and turn it into 5, you would need the reciprocal of 1/5. So all you need to do to have that is use a negative power. So 5 to the minus x equals 5 to the third. And when you have an equation where you have a power on one side, a power on the other, they have the same base. In order for them to be the same, that means that this has to be the same as this. So minus x has to be equal to 3. Otherwise, x has to be negative 3. So the negative kind of flips this 1/5 into 5. And then 3 would give you 125. So you need a negative 3 on the left in order to make it the same as the right. Is that okay? I'm going to look at number 6 because for me it's very similar to the one we just did on number 4. But this one's an equation. I'll do it on the right in a different color maybe. So now I have 1/5 to some power, which is an expression in this case. But just remember, x is an unknown number. Once you know what it is, that's going to just be some power, some number. So don't worry about it being an expression. All right, and just like the last one, they're very similar in these two forms. Instead of having 1/5 to some power equals 5 to the third, we have 1/5 to some power equals 5 to some other power. To make 1/5 5, I just need to put a minus in the exponent. So I'm going to make this 5 to the minus x plus 10 is equal to 5 times 2x minus 1. And now, again, once I have an equation between two powers with the same base, all I got to do is equate the exponents, and then they will be the same number on the left and right. So if I distribute the minus, I'll get minus x minus 10, 2x plus 1, and then I'm just going to solve for x. And that would be my answer. minus 3. Oh, did I do that wrong? Minus. Oh. Oh yeah, I had to. This was a minus one. Sorry about that. Minus 1. If I add 1 to both sides, I get minus 9. Minus 9 divided by 3 is minus 3. That's what I should have had. Theirs is correct. This was negative 3 as well. Going back to 5, we have a half-life. So that tells you how long it will take to reduce to half. So those are like the questions 6 through 10 on the last homework where you had exponential decay. So we're going to take our starting population, which is 100 milligrams. We're going to multiply by, our factor will be 1/2 because we're decaying, so it's going to be a fraction. And then we're going to have t over 1590 because that's the amount of time it takes to multiply by 1/2. So I will write that out. And they want to know what's going to happen in 1,000 years. So I start with 100 milligrams. The half-life equals 1590 years. How much do you have in 1,000 years? That's the question. So we're going to use that formula we had before, that the population as a function of time is equal to the starting population times the 1 over the factor times t over the period. So my starting population is 100. My factor is 1/2 because we're talking about half-life. And then it's t over 1590. And then we're going to plug in 1,000 in for t. So I want whatever that is. That should be about 64.67. I don't know how far they want to take us decimal wise. Okay. At least 2, so that's 64.67 should have worked. This one is like the first 5 questions from the last homework. We have a doubling period, so the factor would be 2. It's going to be every 10 minutes, so t over 10 will be the exponent. And the starting amount is 90,000. Oh, I'm sorry, after 100 minutes, it's 90,000. That's our equation. We have a doubling time. And after 10 minutes, it doubles. We know that after 100 minutes, it reaches 90,000. So 2 to the 10th is 1024. If I divide by 1024 on both sides, my initial population is about whatever that is. Approximately. So as a function, I would write good. And then after 3 hours, that would be 180 minutes. I should get this.
I think you always can go
So I want to do that's 2 to the 18th. 2 to the 18th is
You know what happened at
that.
So, Cody, cut it. I was doing it on accident. You wanted to slap me.
So I get approximately this. Is that correct?
You like, just being nice.
I wonder if they'll take it.
You know, I feel like you try to get under everyone's skin.
Not mine.
It's not like it's like
It
you're
did
not
accept
free,
it?
but you're just-
So I was a little off from what they had, but they're going to take within a range. Just depends on how many decimals you put here.
Why don't you have 19 text messages from the group chat? Can't on the road.
I was not mad at that, sorry. When you're 28, that's not a job.
Yeah, it's like,
I didn't do any of
it's
it.
so, I did 1 through 10 the first day, I didn't do any. That's,
I have.
dude, I'm sure we played return it by the day, and I like that one. Oh, hell, I'm not even 58, so I said.
So we have 1,500.
I still try.
We're going to say times, it doubles every half hour. That's every 30 minutes. Yeah. Yeah. And so they want to know what happens after 60 minutes. So I'm going to double twice. That's times 4. So 4 times 1,500 is 6,000. This becomes a 4. And that makes 6,000.
Dude, is that?
I wonder if it'll take that. I want to see if
No.
I'll see if it accepts that. Find the size of the bacterial population after 4 hours. I'll do the same thing, but 4 would be 24, 240 minutes. It should come out to that. It takes it in that form. Interesting. Nine is a little different. It's a lot like the questions 11 through 15 on the last homework. You have a starting amount, but you depreciate at a percentage. So instead of that equation on the right on the board, the plus R, you're going to say minus R because you're going to go down by 5%. So instead of 1.05, I'm going to do 0.95 because I'm decreasing to 95%. And then they want 13 years. So I'll write that. Okay. We're going to say the amount is the starting amount times 1 minus the rate this time. So if I lose 5%, that means I'm going to be at 0.95. 13 years, and I started with 27,500. That should give me approximately 0.91-ish. So I went down a little bit. Well, quite a bit, about half. They said round to the nearest whole dollar, so I would round down. Well, I guess round up in this case.
You just had one sole year.
I've had maybe 5 my whole high school career.
Exactly.
10 is like, it's increasing by 8%, so that's like the last 5 questions of the last homework. So that'd be 3,000. That should give you that answer. That's another one like those. 5% increase. So it's 1987, it was 5, 2% a year. And we're going to 95, so that's 1, 2, 3, so 8 years. Yes. So I get 5.5 billion. You want 2 decimal places?
What?
Yeah.
Move!
Okay, this one. I think that's it, right? Yeah. We gotta solve the exponential equation. 125 times 10, you can think of it that way. This is 5 times 5 times 5. 10 is 5 times 2. I have 2 times 5 to the x. Divide by 2 on both sides. You get 5 to the x is equal to 5 to the 4th. These have to be the same, so x has to be 4. Otherwise, you just divide by 2. You get 625. That's 5 to the 4th. Here's another one with half-life. Start with 300. 1590 is the half-life. 4,000 years. It's the exponential decay. Oh, 52.
Oh, does it? Onto Goma, Great Tobacco, House, Midnight Oil, Emma, Gondola, Gum, Incense, Opio,
Okay, exponential decay.
Hocus, Joy Plant.
Begins with 100 milligrams. 33 hours, he has 50. So that's the half-life. It's 33 hours. How many remain in 52?
I don't know if that's
So 100, 1/2 to the t over 32. In this case, t is, 33, sorry. T is 52. So about there. There you go.